Hello and welcome back to Atomic Math. Today we're going to do a little chemistry. We're going to calculate the theoretical yield. But before we do that, we're going to talk about the concept of a limiting reactant. Let's start with a real-world example. You have several friends coming over to visit, and you want to make some sandwiches to feed them. Each sandwich would take 2 slices of bread, 1 slice of cheese, and 4 slices of deli meat. So you go to your fridge and you look and see, what do I have? You have 18 slices of bread, 8 slices of cheese, and 24 slices of deli meat. So the question is, how many sandwiches can you make with what you have? Well, let's take a look. We can make 9 sandwiches out of the bread. We could make 8 sandwiches from the cheese. We can only make 6 sandwiches from the deli meat. Now, even though we have plenty of bread, we can't make anything more than 6 sandwiches because we don't have the ingredients for everything. That means that the deli meat is our limiting reactant. It limits how many sandwiches we can make. So basically, we can make 6 sandwiches. That's the whole concept of a limiting reactant, and whenever you're calculating theoretical yield in chemistry, that's what you want to find first. Which reactant is going to limit how much product you're going to make. So let's take a look at an actual question. Propane combusts in oxygen according to this equation. So we have propane plus 5O2 goes to 3CO2 plus 4H2O. So if we had 22 grams of propane and it reacts with 85 grams of oxygen, what is the theoretical yield of carbon dioxide? So the important thing to remember with this is to use the sort of cross multiplication. It will help you from making mistakes, and you can make sure that you've got your units all canceled out, and that tells you that you've done it correctly. In this case here, we're going to start with our 22 grams of propane. And I'm going to say, okay, well, 1 mole of propane is 44.1 grams. Now you can see that my grams are now going to cancel, and I'll be in moles of propane. Now I'm going to multiply it and say, well, 3 moles of CO2 for every 1 mole of propane. So now my moles of propane are canceled, and I'm now in moles of CO2. And of course, if I multiply that through, I get 1.5 moles of CO2. So I know that that's how much CO2 I can make from 22 grams of propane. So let's take a look at the oxygen. So we're going to multiply that by 1 mole of O2, weighs 32 grams, times 3 moles of CO2 for 5 moles of O2, which gives us 1.6 moles of CO2. So you can see that it is our propane that is our limiting reactant, and we now know that we can only make 1.5 moles of CO2. So in order to find our theoretical yield, we need to take those moles and do a calculation. So if we're making 1.5 moles, and we know that each mole of CO2 weighs 44.01 grams, then we're expecting that we should have a theoretical yield of 66 grams of CO2. Let's just say that you did your little reaction and you actually recovered 63.7 grams. What is your percent yield? So of course, in the real world, nothing ever works 100%. There are too many other factors, human error, everything. So whenever we're working with chemicals, we're not going to get that 100% yield. So let's look at how well we did in our experiment. In order to find the percent yield, I'm going to take this 63.7 grams that I actually recovered, divide it by the 66.0 grams that I was theoretically supposed to get, of course, times that by 100, and that gives me 96.5. So I had a 96.5% recovery. So as you can see, these questions are not that difficult. You just have to figure out which is my limiting reactant, and then once you do, use that amount to figure out what your theoretical yield is, and then usually they're going to also give you what you actually recovered so that you can calculate your percent yield. So I hope you found this video helpful, and if you did, go ahead and hit like, and if you want to see more videos like this on math, chemistry, and physics, go ahead and hit subscribe, and I will see you in the next video.